Okay, I'm going to go ahead and get started. This is the last of the Postgres Day talks. Thank you everyone for being here all day. My name is Joe Conway. I work with Creditive USA, another PostgreSQL consulting company. You can see my email address on here. My personal email address, I think I have it on the last slide for questions. It's mail@joeconway.com. And just so you know that this presentation will be available if you go to www.joeconway.com. You'll see a list of presentations, and this one is down on the bottom now. I put it there this morning. So this slide deck is actually a slide deck that came from like an hour-and-a-half tutorial, and I only have an hour to give the thing today. So by necessity, I probably will not be able to cover it all. The first 50-some-odd slides are basically what I would call a deep dive into functions in Postgres. And so that's what I'm going to concentrate on. The end of it, about 26 or 30 slides, is all examples. And so if I don't get to that, which I probably won't, just don't hesitate to contact me personally if you've got questions, but certainly you can download and look at all those examples yourself. Okay? So first of all, I mean, you've heard people talk about functions if you've been here most of the day. You heard Jim earlier talk about some of the dangers. I'm going to focus not on how you should or shouldn't use them, but more about all the ways that you can use them and all the things that you can do with functions in Postgres. Functions are full-fledged SQL objects in Postgres, and quite a bit of the rest of the functionality in Postgres is built on top of functions. And that's one of the key ways that Postgres is extensible, is that you can basically write your own functions but plug it in interesting ways to expand the capabilities of the system. It's also a fundamental part of the system architecture. So most people have probably seen how you create a function, but like I said, I'm going to go into that in great detail. You can execute functions. In case you didn't know, you can execute them in the target list, so it would be in the select whatever instead of a column name. You can execute them in the from clause, so select star from some function. Or you can execute them in the where clause, so you can use them for filtering or a predicate. How are they used within the system? Well, obviously, functions are used as functions, but they're also underlying operators. So we'll see later how you can extend Postgres and add a plus operator that takes two strings and concatenates them. Data types are all based on functions. If you want to create a custom data type, you basically write an in function and you write an out function. The in function says, take this string and convert it into some binary form that gets stored. And the out function says, take this binary thing and expand it into a rendered form that I'm going to display to the user. All the index methods, particularly B-tree, with any kind of a data type in B-tree, in order to have an index built on that type, one of the fundamental things you need is a comparator function that returns a negative, a 0, or a 1, depending on whether the first value is less than, equal to, or greater than the other value. So again, you can extend index methods by adding functions. Casts, triggers, we talked about triggers in some of the earlier presentations. Aggregates, this is another really useful thing that I've used before. You can write your own kinds of aggregate functions. And again, I've got examples of that. The new ordered set aggregates that Josh just talked about. And then window functions, which were also talked about a couple times today. So all of those things depend on functions underneath. So in terms of what forms they can take, there's basically 4 different kinds. There's SQL functions, which are really just native SQL wrapped inside of a function. There's procedural languages, so PL PG-SQL is a procedural language, PL Perl, PL Python, all of those things. Those are basically where we're plugging in some sort of a library that's going to know how to parse the text and do something with it. So you're plugging into some other kind of language into Postgres. Then there's internal functions. Basically many of the functions that are built into Postgres are designed to be called from the SQL level, and I'll show you how you can actually use create function to create aliases for those if you want. And then you can, of course, write C language functions. Postgres is natively in C. There's an API for writing your own functions in C. The arguments can be base, meaning all of the base types, integers, text, arrays of different things. They can be composites, so they can actually be tuples that have multiple fields, or they can be combinations of those things. They can be scalar or array. They can also be pseudo or polymorphic, and I'll get more into that in a little while, but that adds greatly to the capability of functions and to the flexibility of functions. You can do variadic arguments, which means you can have one or more argument and it will call the same function. And arguments can be in or out or in out, which means an in argument is one that's going to obviously go into the function, be used by the function. An out argument is one that's being output by the function. Again, I'll show you examples of how this gets used later on. And an in and out is something that would be coming in and going out of the function. For return, you can do a singleton return or you can do a setup. So you can, when you call a function, it can provide one row, essentially, all the time. Or you can, there's a syntax for allowing you to have it output multiple rows, possibly. And there's differences in behavior depending on how you, when there's no rows at all, basically, depending on how you call it. You can return base or composite types again. You can return pseudo or polymorphic types. So SQL functions, the behavior of SQL functions is it's essentially an arbitrary list of SQL statements that are separated by semicolons. So just like you might see in a file that you pipe into pSQL. The key thing to understand is it's really only the last one that's going to determine what that function returns. So the last thing that you call in there that returns a value is going to be what gets returned from that function. The arguments can be referenced in the function body using either the name in recent releases. Actually, I forget when we added named arguments for SQL functions. It wasn't all that long ago, maybe 9.2. But in the last few releases at least, you can provide a named argument. I'll show you those. Or you can reference the arguments by $1, $2 type of thing. If your argument is a composite type, you can reference it by saying $, and then field name. But you can only use those arguments as data values within the queries that you're writing. You can't use those as identifiers. So in other words, you can't pass in an argument to a SQL function and then have that be the name of the table that you're querying from, or the column that you're querying from. If your return type is singleton, and the first row of the last query return null, the function will return null if the last query didn't return a result. But if you select it as, set it up as set of, it's going to return an empty set. So instead of getting one row, you're going to get no rows at all. Procedural languages are user-defined functions. They're written in some language other than C or SQL. Essentially, it's a string that's going to get passed to the parser of some other language. And then that other language is going to take over. It's going to do its thing. And when it returns a result, it gets returned back out to Postgres. So that language handler is dynamically loaded. That's important to understand. When who was it earlier that was talking about Jim was talking about the testing earlier, and I asked him whether the language was preloaded, and that's because if you connect and then execute something in PL, PG-SQL, or PL Pro, the first time you execute one of those functions, that shared object has to get loaded. But if you preload it, it'll be there already. So if you're doing lots of connecting and disconnecting, you would want to preload.
Is that true for PL/PG/SQL? I thought that was actually built right in.
No, it's still true for PL/PG/SQL. Now, PL/PG/SQL is pretty lightweight. And like I said, you know, in most sane applications, you're not connecting and disconnecting for everything you do. You're connection pooling or whatever. So the cost of doing that load is not necessarily a huge issue, but it can be if you're not doing things that way.
Should preload libraries will influence this one because it will load the shared object at the postmaster and then inherit each.
Right, that's what I was referring to when I said you could preload the libraries. But that is the parameter. Actually, I know that because I wrote that patch. Internal functions are statically linked. So unlike PL/PG/SQL, an internal function is one that's adheres to the protocol that Postgres, we call version 1 protocol, which makes a function callable from a SQL level, and there's a number of those functions that are just built into the back end. And so here's an example of one. It's called d square root. It's just for a square root with a double data type. And if you wanted to, you could say create function square underscore root to rename that thing. It takes a double precision argument, and then it just calls that internal symbol. Also note that on a lot of these slides, I've given you URLs right into the Postgres documentation for the things that are being talked about on the slide. So if you download these slides and you have specific questions, many of the slides will have URLs, so you can just drill right into the documentation. C language functions are user-defined functions written in C. They are compiled and they're dynamically loaded, just like when I was talking about the procedural language handlers. So they have the same issue. If the load time is significant, you might want to use shared preload libraries. Shared preload libraries, by the way, also supports basically an init function, something that gets called when it first gets loaded. So if there's some kind of expensive setup that you need to do, you can do that, preload everything, and then make your calls as cheap as possible. They do require that you use this PG module magic is a macro that you have to have in the C code, and that's basically to make sure that this library that you're loading has been compiled against the specific backend you're trying to load it into. Years ago, we didn't restrict that, and we would have people loading versions, you know, extensions that were compiled in one version of Postgres into another version of Postgres, and weird things would happen, and they were difficult to troubleshoot until you figured out what was going on. So these days, you can't do that. You have to have this PG module magic. It'll make sure that you have the right version for your version of Postgres, but it also means you're going to have to recompile your extension whenever you do an upgrade to a major version, not within minor versions, but if you go from 9.3 to 9.4, you're going to have to recompile these things. And I say in here that there's a short example later. I'm not going to have time to get to that in this tutorial, but again, come see me if you want to see some examples. There's lots of examples of this kind of thing in the contrib directory. Also, if you download the Postgres source, there's a bunch of examples of it. In terms of language availability, again, you saw some of this in earlier presentations. The ones that are shipped with Postgres are PL/PG/SQL, PL/Perl, PL/Python, PL/Tcl. There's loads and loads of other ones available in various states of repair and maintenance. Not so sure. I think I've heard recently that PL Java is not all that well maintained. Can anyone confirm or deny that? Because maybe no one's using it. PL/V8, which is the JavaScript language. PL Ruby, PLR, which is the one I wrote. PL Bash, which will let you do shell. It's Peter Eisentraut, and there's loads and loads of others. Okay, so now let's get to the real meat. This is right out of the documentation. This is the syntax for create function. You can see there's a lot going on here. And so what I'm going to try and do, probably for the bulk of the time I have left, is go through this in a fair amount of detail so that you can see what all of these things do. Because if you've never really focused on this, you've just created simple functions, seems like, yeah, creating a function is easy, but there's a lot of devil in these details. Before we get into all that, I just want to talk for a minute about dollar quoting. Who knows what dollar quoting is? So, actually not all that many people. Dollar quoting is a way to quote a string literal in Postgres, and it really does work for any string literal, not just for the body of a function. But the basic idea is if you have a dollar sign, another dollar sign, and optionally you can have a tag in between the dollar signs. And that will delimit the string on either end. And by allowing that, now you can have single quotes inside of your identifier that don't have to be doubled up. Because if you go back in time with Postgres, used to be people would write PLPG SQL functions, and if you were doing, string concatenation and then executing the strings, you would end up with doubled and quadrupled, and I've even seen 8 or 16 single quotes in a row in order to, depending on what your nested level of evaluation was going on. So it got pretty ugly. With dollar quoting, it's really nice. You can have different tags for different identifiers at different levels. So you can basically, you can nest these things as long as you make them different, and it keeps your code nice and clean. I also want to talk for a minute about anonymous functions. Again, I guess, I tend to think of a lot of things as being fairly recent because I've been with Postgres since like 6-something. The do, when was do added? Do you know, Bruce or Josh? So that's in all released versions at this point? Yeah, I thought maybe it was added in like 9.1, but in any case, do is an anonymous function. So, or you might, it's not exactly a Lambda function probably, but it's basically you're creating and executing a function on the fly without having to define it. And there's a variety of reasons you might want to do this. There are some limitations on it. You can't return values from it, for instance. That's one of the limitations. But this is really useful for administration kind of work, where you want to loop through a table and do some action based on it, maybe insert some rows or whatever. And again, I'll show you an example of that in a minute. It can be written in basically any of the languages that Postgres supports, which means by default it can be written in PLPG SQL because Postgres automatically comes with, maybe this is what Jim was really referring to. Postgres, in the old days, you had to specifically add PLPG SQL as a language. These days it comes by default in template 1, which means when you create your first database, it's already there. So it's already there available for use. But if you have created PL Perl as an extension or whatever, you can write do functions over the PL Perl. You just have to specify that as a language. So here's an example where I'm basically looping through some system catalog tables. I'm going to find all of the users that belong to the group that's called admin, and then I'm going to alter those users, and I'm going to bind a specific configuration variable to that user. So I'm saying that all of the users in the admin group, in this case, are going to get work mem set to 512 megabytes, which you probably wouldn't want to do in your PostgreSQL.conf, but maybe if you had an ETL user or some special user, you want to allow them to have a larger work mem than your common users, this is one way you could do that. And with this do function, I can just get them all in one shot and not have to type it out manually. So you can see, this is not obviously a function, but this is how you would query to see whether that had taken effect. And after I ran that query, I've got a role name called Rockstar, and his work mem is set to 512 megabytes. So again, you can download the slides and you can see how this system catalog lookup was done. It's fairly straightforward stuff, but if you're not familiar with Postgres catalogs, it might be interesting to you. So once you've got a function created, what happens if you want to change it? One of the problems is that you create a function, it can have other dependencies. There could be triggers that are dependent on it. There can be views that are dependent on it. If you had to drop that object every time you wanted to change it, that could end up having a cascading effect. Literally, you might have to do drop function cascade, which would affect a bunch of other objects that you may or may not want to do. And so there's this notion of create or replace. Is everyone pretty much familiar in Postgres? A lot of objects, we have the ability to do create or replace. Is people seeing that pretty much? So all the places we do that, it's really for that basic same reason. It's that we want to be able to change the definition of something in place, but we're doing it in a way that it shouldn't affect the dependent objects, and therefore we don't want to have to cause all of that grief of messing with all those dependent objects. So if you do create or replace, it'll change it out right from under everything. And the reason it can do that is because basically everything is referring to these not by name but by an OID, and we just make sure we replace the thing with the same OID. You cannot, however, do that if you've changed the function name, if you've changed the argument types, if you've changed the return type, if you changed any of the out parameters, because effectively that changes the return type as well. And again, I'll get into a little bit later about why the argument types are particularly important, but we support polymorphism in Postgres, so you can have the same function that operates on different numbers of arguments. So each one of those is going to be a separate function definition, and the way Postgres is going to differentiate them is based on the arguments, because now the name isn't unique enough. So in terms of the function arguments, this is the part of the syntax for the function arguments. There's an arg mode, an arg name, an arg type, a default potentially, or an equal sign, a default expression. And you can have multiple arguments, obviously. So arg mode is this in out, or variadic. So if you omit the arg mode, basically it's assumed to be an in argument. And if you've got out or in out, you cannot use that if the function is going to return table, which I'll get to later. Variadic argument types can only be followed by outs, and that's because the underlying implementation of variadic is basically, if I say I've got a variadic integer, under the covers, Postgres assumes that it's an array of integers. And since we don't know how many there are, at that point we can't resolve two different functions based on the signature, so we have to assume that it's just an array of whatever that type is, and you can't have any additional arguments that are going to add to that signature. It's not necessarily required, but it's good style if you kind of have the in arguments followed by the in-out arguments followed by the out arguments. And as I alluded to, the function name plus the in-out, plus the in, plus the in-out arguments, plus the variadic, that is the signature that identifies one function from another function. And so in this example here, I've got an in argument, an in-out argument, and an out argument. When I call that, and I'm just doing, this example is kind of just a contrived, I'm combining the arguments in some way, and when I call that with the two arguments, you'll see I get two columns back because I've got an in-out and an out. Any questions on that?
If you had all three of them as in, and you could still return a record which would return, I mean, you could return the record irrespective of having them as in, out, or out, right? So what's the one? Why do you want?
You're going to see examples of this later, but basically if you don't have out arg mode arguments, you will have to at runtime specify what the out columns are. So you have to have a column definition at runtime. Postgres always needs to know at runtime what the column definition is of what you're outputting, so that it knows what to do in terms of joining it with other tables or whatever else you're doing with this function. And so there's got to be a way to derive that information. If you've got out arguments, we already know what it is.
So is it advisable to use a pipe instead then, where you create the pipe with whatever the column that you want?
I would think that's kind of a style question. If your function, and again, I'm going to have lots more examples of this, so I'll just try to answer this quickly. If your function potentially returns a variable number of columns, some functions, like in dblink or crosstab is another one, where every time you call it, it might return a different number of columns, right? And so for something like that, you can't really pin it down to a type very easily, and you're almost kind of have to at runtime specify what you expect. But if it's something like this where you know it's always 2 columns, yeah, you can specify it to return those 2 columns. There's other syntax that's, again, been added in later releases for convenience. We'll see that when we get to the return types. There's other ways. There's about 4 or 5 different ways that you can do this, and there's probably no real advantage in terms of performance. It's really a matter of style and readability and what you prefer. So the arg name is optional. You can define the function arguments without a name, but if you have a name, not necessarily all languages, I think these days pretty much all of the most common ones will make that name available inside of the body of the function to be referred to. So in PL/PG/SQL, for instance, whatever name you give it, you're just going to refer to that argument within your function body as that same name. You can also do the $1 in PL/PG/SQL. Again, depending on the language, it'll be handled slightly differently. So in this case, I've got that same basic function, except I've now named my arguments. I've got, I don't know how readable this is in the back, but I've got A, mult, and I'm defining out as A, in fact, and you can do this. So now when I do that same operation, I'm using the names of the arguments instead of the $ syntax. And here I'm showing you how to assign a value to a named argument, and basically now I'm calling this function with those arguments out of order, but since they're named, I can do that. Arg type, this is the one absolutely required part of the arguments. This is the data type of the argument, so Postgres knows what to expect to come in. It can be schema qualified, so if you've got kind of a custom data type, or maybe for something like a PostGIS data type, and you don't have PostGIS in your search path or something, I've actually seen that. You might have to schema qualify the data type. But this can be base type, array, composite, domains. It can actually be a reference to a table columns using this kind of syntax where you say table name dot column name %type. And this can be a polymorphic or a pseudotype. Or any element, any array, any non-array, any enum, any range. And the way these things work is that you're writing a function that can take at runtime potentially one call, it might take an integer, and the next call it might take text. And the only thing that Postgres is going to enforce is that if you've got 2 arguments that are both marked as one of these any types, or an argument and a return returns can also be marked with an any type, that they're all consistent with each other. So if you've got an any element and an any array, and the argument is an integer in one spot, then in the spot where you have any array, it better be an array of integer. Does that make sense? So again, here's an example of one where I've said A and mult are any element, and I can pass in numbers, and it's just going to take them. I've got other examples later where I show you the same function basically, or doing different things with different data types. You can define a default expression. So if you don't provide an argument and there's a default expression, that'll get substituted. It needs to be coercible to that argument type that you've defined. And basically any of the ones that are inputs to the function can have this. But once you've used the default, all the rest of them must have defaults. And again, that's to help Postgres be able to resolve which specific function you're calling if you do leave out those arguments. It's going to make a choice based on what you've provided and which defaults are available. Okay, so we talked a few times about function overloading. Here's a case where I've created the same function named foo, and they both return text, but one version takes an integer, the other one takes a text. And so now when I call that same function name, and in one case I give it a string, 42, and the other case I give it the number, 84, you can see that each of these functions was called appropriately based on the input that I gave it. So now we get to return type. Again, very similar to what we just saw with the argument types, at least at some level. You can return base, array, composite, domain types. It can be the type of a column. It supports those same polymorphic types that we were talking about. But then there's also a number of special pseudo-types that are related to return values that are used for certain types of functions. So if you've written a function that implements one of these procedural languages, it has to return a type called language handler. If you've written a function that you're going to use as a trigger, it needs to return a type called trigger. If you return a type called record, that means I'm going to return basically a tuple, a column definition list, but I'm not specifying what it is. And you can also say I'm returning void, in which case you're not going to return anything from the function. So in terms of the return type, if you've specified, this is the syntax for the returns, you can either say it's a specific return type, or you can say it returns table and provide a column definition list. So this goes back to the question that we heard earlier. I can actually, this is a again, I can't remember exactly when it was added, but it's a relatively new addition to the syntax where you can say it returns a table, and here are the column names and the column types right in the function definition. And so if I know this function is always going to return the same columns of the same types, this is a fairly convenient way to allow it to do that so that you don't have to specify that at runtime all the time. And you don't have to create a special type, and you don't have to use out variables. If you do have either the in-out args or the out args, you can actually leave out the returns clause. But if there is a returns clause and you're using out args, they better match up. And if you expect your function to return more than one row, whether what you're returning is a scalar value, just one column, or if it's a composite type where there's more than one column, in either case, if you expect more than one row, you need to mark it as set of. If you don't mark it as set of, you'll only get one row, even if what's going on inside is trying to return more than one row. So here's an example of a function that has out variables but no returns. So I've said test bar1, it's got two columns that are both out, F1 and F2. First one's an int, the second one's a text. An interesting thing that I think some of my other examples had this, but I'll point it out now. How many people have seen this kind of syntax using the values clause? You realize that values, just like you have in an insert statement, when you say insert into table values, and you can say parenthesis, some set of data, comma, parenthesis, comma, parenthesis, you can specify multiple rows that way. Well, that works standalone just like a subquery would. So this is kind of a convenient way to materialize data for like testing purposes, or if you've got some small data set that's always the same and it's really small. I mean, if it's anything larger than a few rows, I'd probably have a table for it. But if you want to just materialize something in memory all at once, this is a great way to do it.
You can do that with a view too.
Yeah. I mean, you literally, when you say values, it operates just like you said, select, you know, in this case, 42, comma, hello, union, select 64, comma, world. It works exactly the same way. This is an example of out plus set of record. So I've got two out variables. I've said that the function returns set of record. And because I have the out variables, when I call that at runtime, I can just say select star from that function, and I get my rows and columns. This is an example of creating a custom type. So there's a syntax for creating a type that doesn't actually have a table behind it, rows and columns in a column definition list that have no actual table or view behind them. So if I say create type, whatever I want to call it, has two columns, F1, F2, int and text. Now when I create this function, I can say it returns set of that type. So this is yet another way to do the same thing. And as we talked about earlier, I can say, right in the function definition, it returns table with, again, that same column definition list. So here's now a third or a fourth way to achieve the same thing. So as you can see, I don't know of any kind of reason one would perform better than the other, but it's sort of a matter of what you prefer as to which one you use, I think. Now here's an example of one that has an unspecified set of record. So because I've not specified anything, Postgres has no idea what this function is returning. And even though in this case the function is always going to return the same two columns, Postgres has no way to know that. So when I call that thing at runtime, I have to specify the column definition list by aliasing the function and giving it a column definition list. So in this case, at runtime, I'm going to say select star from test bar 5 as T, and I'm going to give it F1 int, F2 text. So I wouldn't recommend doing this unless you actually don't know what columns your function is going to return. Here's an example of a function that returns scalar. So you can actually do this without returning a record type at all. It can just be a simple type, a scalar type like an integer. As long as you've defined the function to return set of, you're going to get multiple rows if your function outputs multiple rows, even with a scalar data type. And this is a way that you can specify the column name for that scalar data type. So you notice that when in this example, if we go back a slide, it just used the name of the function as the name of my column. But if I want to specify that that column, when it outputs from that function, should be called F1, this is what you would do. You would say as table alias, parenthesis, column alias. So that can be useful. I use this all the time when I'm using, there's a built-in function called generate series that is often used for testing and similar purposes, administrative purposes in Postgres. And it basically just spits out numbers from whatever to whatever. So you say select star from generate series 1, comma 10, and it's going to spit out the numbers 1 through 10. But that column name is called generate underscore series, which I'm too lazy to type. So I usually say as T parenthesis I close parenthesis or G whatever. So I alias it as G dot I a lot of the times. So it's just easier to type. Now this is an example if you've got a function that returns a composite type, but you call it in the target list instead of in the from clause. If you notice, this looks a little different in that I've got the same data, but it's now wrapped in parentheses and it's got a comma between it. And that's because this is what a full row type looks like when it's rendered through its out function. So that's maybe useful for some things, but it's not generally useful for a lot of things. There is a way that you can expand that again, however, so you can do this, where you have to wrap the function call in another set of parentheses and then say dot star, and now it'll expand it into actual columns. There have been some reasons that people would do this in the past. I think for certain types of functions, not PLPG SQL, but I think SQL functions can be not materialized in memory, but rather pipelined, meaning they get spit out as they get created. But that's not supported if you call a set returning function in the from clause. Still today, I believe, it's still not. No one's fixed that yet, right? I don't think so. And it actually does work on the target. But I think it's only for SQL functions. I think that's the only one that's been implemented in such a way that it will basically do a pipeline. So that means instead of having, let's say you're doing this with 10 million rows in your function, in a set returning function in Postgres, if it's not pipelined, which is virtually everything that you use set returning functions for, it basically creates all those rows in memory and then spits them out or does whatever it's going to do with them. But when I say pipelining, I mean as each row is generated, it can be sent out to whoever's making the query. And by doing this type of method with us, if it's a simple enough function in SQL, I think it gets pipelined. So now we're down to the attributes. Let me just do a time check. Probably good. So again, you saw in that first slide with the syntax, there's a whole bunch of different attributes that can be tagged onto these things. One of the ones that you'll have to have generally is a language attribute. That's going to specify to Postgres what language was the thing written in. So it can be SQL, it can be C or internal, or it can be one of these loaded procedural languages. There's an attribute, if you want to make a function a window function, you've seen some examples of that. I have an example of that at the end of this slide deck that I'm never going to get to today, but you can go look at that when you download it offline. We've seen some examples of window functions, I think in Josh's talk a little bit earlier. But basically, if you create a function and you want to use it as a window function, you have to declare that at the time when you create it. Does everyone kind of know what window functions are? Anyone not? Raise a hand. So the basic idea of a window function is it's similar to an aggregate in that you're doing an operation on a set of rows, but in an aggregate, that set of rows is compressed into one output row. With a window function, you've got access to everything in that set of rows, but you're going to get something returned for every row in that set. And so you can do things like look ahead or look behind. You can say, I want to do some calculation based on my current row minus the data from the previous row. And then there's all kinds of other things that you can do with it, but things like ranking, if I want to take all the stuff in a group and I want to rank them 1 through 10 in some sorted order, I can do that with a window function. Lots of neat stuff you can do for analytics, but that's probably a whole other talk. There are a bunch that are built in. This query here on the slide shows you how to figure out what's built into Postgres in terms of window functions. This table pg_proc is where all of the metadata for functions lives, and there's a column called pro_is_window. It's just a Boolean, true or false. So if you just select out of your system catalog, you can find out which are the built-in or which are the window functions that are in your database right now. And obviously, if you haven't created any, it's just going to be the built-in ones. Okay, volatility. Volatility is something where you as the function writer are kind of making a promise to Postgres, because in many cases Postgres has no way to know whether you're lying or not. But it's a bad idea to lie, and I'll try and explain why. A volatile function is one that can literally return a different result every time it's called, even within the same query. Whereas a stable function is one that's going to return the same result if you pass it the same arguments within the same query. An immutable is one where whenever I call this function, if I pass it a certain argument, a specific argument value or set of argument values, it will always give me back the same result. And one of the reasons it's important to understand this is because if you want to build indexes on expressions, they have to be immutable. Because you wouldn't want to build an index on something and then later on have the definition change on you, right? That would produce useless and surprising results. And like I said, there's really no way for Postgres to know for sure if what you're doing is immutable or stable or volatile. So you really need to understand what you're doing. If you're going to mark something immutable so that you can, one of your own functions immutable, so that you can use it in an expressional index, you better make sure that you're really sure that it's immutable. And there can be some surprising things that are not immutable. So for instance, if your function is outputting a time which has a time zone on it, which is a time with time zone, basically the value that's rendered is going to be affected by the time zone setting Postgres, then even though you may not think of that as ever changing, there's nothing to stop someone from changing the setting for time zone. And the next time you call that function with the same input, it's going to give you a different result. So here's an example. This is a query that you can see which built-in function, again, functions that are currently installed in Postgres that are, and what type of volatility they have. And in this specific case, I'm just going to look at 3 functions that are built in so I can show you this example. I'm going to look at the lower function, the now function, and the time of day function. And you can see that lower is immutable, now is stable, and time of day is volatile. So go back to what I was just saying a minute ago about the differences in those functions. If I run this query, select lower over ABC, now, time of day from, and here's that generate series I was talking about. In this case, I'm not really using the output of it, I'm just using it to generate 3 rows. You can see that the lower of ABC from one call to the next is exactly the same, right? The second column is the output of now. The now column is the same for all 3 rows within each query, but it's different from one query to the next. But time of day is different on every row in both of those queries. So that's the basic difference there. Next section is behavior with null input values. So by default, functions are going to be called if you have a null input value. The problem is that nulls sort of behave different than real values in a lot of cases. And in particular, if your function is a C function, if your function is not prepared to deal with properly when it receives a null, again, unexpected or bad things could happen. If you have a C function and you don't handle a null correctly, it's going to crash if someone passes it a null, and basically anything that crashes could be potentially co-opted into a security issue or whatever. So you need to make sure, and again, this is a case where Postgres is trusting you to make the right call. So here I've got 2 functions. One of them returns null on null input, and the other one is called on null input. The other thing, when it returns null on null input, is it skips the whole function call. So basically, if the function gets called with an argument that's null, and you've defined it as null on null input, it just immediately returns with a null, which means it'll be a lot faster than if it goes into your function and your function ends up spitting out a null. So if ultimately your function is just going to return a null, you should define it that way, because it's going to be a lot faster. Okay, this one takes a little bit more to wrap your head around. I've got a pretty decent example here, and again, this was only a few releases ago this was added, but there were cases where people would use views to try and do security. So they would have a view where they're filtering the rows based on who the currently logged in user is. And their hope was if they only give the user access to the view, then the user can't get to any data that they shouldn't be able to get to. The problem is if you do things in a crafty enough way with a function, you can see the data for the rows that weren't returned. And I'm going to show you an example of how that works. This leak-proof, again, it's a promise that you, as the writer of the function, is making to Postgres, that you're saying that my function is not going to leak any data, because I know that I'm doing something so straightforward with it that it can't. And you would not want to define only, first of all, only a super user can create a function that's defined as leak-proof. You would want to only mark a function as leak-proof if you're sure of that. And if you don't mark it as leak-proof, effectively you can't depend on the fact that a view that's using this function is really not going to leak any information. So now I'm going to go through the example. So you'll see on most of these slides I've tried to make everything as complete as possible so you could literally cut and paste from my slides to test the stuff out. So first I'm going to drop a table if it exists. I'm going to create the table. I'm going to insert some dummy data in it. In this case I'm inserting basically books belong to two users named Joe and Tom. I'm going to create a view over, I'm going to call it user books, and it's going to select ID, the user, the book name, and the price from the all books table, but it's only going to select me the rows where the user is equal to the currently logged in user. So this is where I'm trying to enforce, if Joe's logged in, he shouldn't see Tom's books. Now here's where someone gets crafty. If they created this function, leak info, and all this thing does is it says if the argument to that function is not equal to the current user, I'm going to do raise notice, which throws up a notice in the pSQL terminal, and I'm going to show you what that data is. And then I'm going to return a 0. And the important part here is again, someone earlier talked about this, but I can tell the optimizer, maybe it was Bruce, I can tell the optimizer that this thing is very, very cheap. So now if you look at a query, select star, I logged in as the user Joe, and I say select star from user books, my view, where leak info equals the username and the book name equals 0, because I know that thing's always going to return 0. Now, all of a sudden I get these notices that show me Tom's books. And the reason for that is shown in this query plan. If you look at this query plan, this filter, leak info was basically pushed down into the view. So Postgres goes out of its way to rewrite a lot of things in order to make your queries more efficient. Again, like Bruce talked about with the optimizer. So that involves rewriting of your query. And if it thinks that this function is very cheap, it'll decide that doing that filtering at the lower level in the view is cheaper than returning all the rows from the view and then applying the function. And that's how I get this information to leak. So now if I create the view with security barrier, same view as before. Remember, when I defined this function, I didn't say it was leak-proof. So now when I do that same analyze, you'll see that the filter of leak info happens above what's going on in the filtering in the view. So the view has filtered out all of Tom's rows before the function ever sees it. But now if I go back and I alter that function and I say it's leak-proof, now we go back to where we were before. So this is why basically if you're going to mark a function leak-proof, you better be really sure that it's leak-proof. And that includes keeping in mind that anything that generates an error might include some information in the text of that error that you don't want leaked. So the question is, well, why would you use leak-proof at all? And the reason is if you really know that the function is leak-proof, you get predicate push down into the view, you might get better performance. Security attributes, security invoker, security definer. Has anyone ever seen this before? Again, not too many people. Okay. So the idea here is that it's kind of like on a Unix executable, you can say do set UID. It's kind of the same idea. So if I define the function as security definer, that means whoever was the one that created the function is the one that it's going to run as. But if I set the security as security invoker, it means that whoever is running the function right now at runtime is the one that it's going to run as. And so you can see how that could be useful if you want to create a function that accesses something that you don't normally want the user to have access to, but it does it in a very special way. Then in order to get access to that data, you can create the function as security definer. Now grant access to the user to execute that function. 5 minutes. And then basically they get escalated privileges just for the length of time it takes to run that function. Optimizer hints, we talked about this a couple times now in an earlier presentation. You can specify an execution cost. You can specify what the expected number of results. It's pretty hard to figure out what these numbers really should be. Probably takes experimentation, and generally speaking, there's definitely use cases for it, but this is something that you're probably not going to mess with unless you've got a specific pathological case that you need to fix, and then you're going to do some experimentation and figure out what the numbers should be. And I think I'm getting pretty close to the end, which is good since I'm running out of time. You can also bind, just like earlier when I bound the setting a workmem to a specific user, you can do the same thing with a function. You can specify a configuration parameter, anything that's basically session settable can be bound to the function itself. So every time that function runs, it has that value of that parameter. So you can do things like set search path. You could set a workmem, and now every time this particular function gets run, you don't have to do it globally, and you'll get that value. Okay, function bodies. This is pretty straightforward. It's basically a string literal. We talked about the dollar quoting that makes it easier for you to write a big long function and do it in a sane way when it's got embedded literals and things like that. It's going to be, this is what gets parsed by the language parser. So if you're calling Perl, this is going to be written in Perl, with some special stuff that you can get out of the Postgres manual in terms of how to access the arguments and how to return values. But basically, it'll be written in Perl. It can be an internal function name. It can be the path to a C language object library if the function name exactly matches the symbol in the object library. Now, if you use the syntax object file link symbol, this is basically when you've got a C language function. Maybe you've got a shared object library and it's got several functions in it. And so they're not going to match exactly maybe what the SQL function name is. So this is generally what you'll see people use if they've written extensions that are in C. They'll say object file link symbol. One of the things that's important to understand here is you can do this, I think on the next slide. Yeah, in this slide I show you an example, libdir/plr. PLR would be the shared object library that you're loading. Libdir is kind of a special symbol that gets built into the back end at compile time, which points to where Postgres expects to find these libraries. You can specify an absolute path if you want, but that's not very portable. It's not good if you're going to dump and reload and maybe go to another database where you've got these things installed in a different location. So you're better off usually just using $libdir and make sure that everything gets installed in the normal place for that particular Postgres cluster. So again, there's that example. And now I'm on to the example. So I think I'm going to, and I've got 1 minute left. So I'm going to stop there. Like I said, feel free to contact me, mail@joeconway.com. Go to my website, joeconway.com. You can find this presentation. If you want to send me email, ask some more questions, that's great. I mean, it's the end of the day, so we don't have to exactly scurry out of the room, but everyone's been here all day and everyone's tired and probably wants a drink of something or another. So if there are any questions, I'm happy to answer them now. Like I said, if anyone wants to get to me later, feel free to do so. Any questions? It's www.joeconway.com, JoeConway.com. And my email address is just mail@joeconway.com. Anything else? Thank you, everyone, for coming to PG Day. It was great. Go to my website. Well, fix it. You're supposed to fix it for me.
Okay, well, we still need to work on the, you never showed me how to do it from that side there.
Other people have legitimate questions, aren't they, harassing me, so move out of the way.
What time is dinner?
Oh, that is a legitimate question. We have to be there, I don't know, hey, Oscar, is he still here? How far away is this place? Well, so what time are we meeting and where? In the lobby at what time?
Hold on, I'll get an exact how long it takes right now. Okay. I will look at your slides.
How'd that go? Were you okay?
I had a little trouble, because it was so segmented, I had trouble understanding like where we got to a slide and how that related to the, because you walk through the syntax, right?
Yeah, basically. It was, I should probably call it a deep dive into functions or something like that, but
I picked up a bunch of things I didn't realize.
I picked up stuff when I was writing it that I didn't know, and you know,
I don't know
there's
what
so much there.
it's
It's really,
It's just like a bazillion ways to do almost anything.
and that's part of because a lot of those things got added over time as people said it'd be easier if you could do it this way. It'd be easier if you could do it this way, and stuff just got added.
Yeah.
By the way, I think it's, volatility, it actually does have some checks.
Yeah, actually, maybe.
There's, I know that there's one of those things, because I ran into it, working on my variant data type, where I'm
I
like,
think
oh, I
maybe
can do this in here.
maybe if you do any kind of a query that accesses a table, we detect that. I can't remember. You might be right there.
Yes,
Maybe.
I think it's immutable. I think we check immutable, and if you then try and do anything like an SPI call.
But there's still ways to define immutable functions that are not really immutable. I mean, the fix that people do for the time zone thing, where they still want to create an expressional index, is they build a wrapper function, they declare it immutable, and they just call the underlying function that's stable.
Right.
And you can do that, and if you know, it's a foot gun, right?
Yeah.
You don't pull the trigger, okay. But if you shoot your foot, it's your problem.
So programmers are all, quick question. You were talking about,
Can I just go? Just 1 second. 30 minutes?